Now we do some examples for freehand sketching. So there are 5 examples. I just try to give you some hints how you can easily uh, do the root locus without going in much detail. So first one is we have a 0 and a pole. Okay. So second is two zeros on the one location and two poles on the real axis on another location. Similarly, you have two left hand poles and a 0 and left hand 0 and two imaginary poles, two imaginary 0 and right hand pole. So how we draw this? So we know that for this type of things, first we have to calculate number of poles and zeros. So these are equal, so this means that there's no asymptotes. Okay, so nothing is going to infinity. Now the next thing is look at the real axis. So for real axis we know that there's nothing on the left, so the root locus easily start from this pole and finish at this 0. So this is the overall root locus of this example. Now the next one, we have this point which exists two zeros on top of each other on the real axis. Okay, and two poles. I just make it so that they on the, now if I am here, there's nothing on the left, so when I come here again, this becomes even nothing. Again I come here, this is again even nothing. So this means that nothing on the real axis. Now the thing is how this will work. Okay, so nothing on the real axis, so this means that and we know that always poles start from the root locus start from the pole and end at the 0. So they will go either in that direction or they will go in that direction. Okay, so this is the root locus. So we will here we need to do some calculations. One is or they go in that direction or they go in this direction. So that difference, or they go in that direction. So we have to know which angle we have to use here. Okay, so we will discuss this later when we do the precise calculations. Now third one, freehand sketching here. Now number of poles is 2 and 0 is 1, so this means that 1 is at the infinity. So to do the real axis so that we understand which one is, if we are here nothing on the left, so we have root locus between these two zeros and poles, so means that it will start here and finish here. Okay, now nothing here because again this become even. Now we will move to here, so this means that it will start from here and goes to infinity. So 0 is infinity in this direction. So this is done and it's very easy, nothing we need to do calculations here, and this is the perfect precise solution. Now the fourth one, here I have some imagine complex poles here with some imaginary heights and real number. So when I come here, nothing on the left, so there's no road. When I cross these one again, this is even, so this means that the poles which are in complex, they didn't count for the real axis. Why? Because they are already in even, so they didn't affect it. So nothing here till this 0. When I cross here, it becomes odd, so this means that there's something coming to this 0 and other is going to the infinity. Okay, so we know that there are two poles and 1 0, so the other is goes to 0 is also finished there at the infinity. 0 is at the infinity in this direction. Now how this will move, so the main idea is that there are a lot of possibilities, because we know that the root locus will be start from this pole and that pole, so there are two branches. When one is come here and uh, finish at this 0, other will come here and goes to the infinity one. Now the question is, there are some other information that we need. This pole can be go in this direction, okay, and goes to this one, or this pole can go uh, in this direction, and come here. So this is different angle than this angle, so we need to calculate which direction this will follow. So due to my own experience, it will follow that direction. Okay, and it has some angle, so it has a different angle and it has a different angle. Okay, so and the thing that we need to know this angle, and this is known as break in or breakout angle, or angle of departure is much better. Angle of departure. So in break-in points, and these are known as angle of departure because this is depart from the pole. If there is a zero, it is known as angle of arrival. Okay, so again the next thing, this is j omega crossing that we need to calculate, and we do calculation for j omega crossing using Route's criteria that we studied in previous chapter. So you know that when we have zeros in the row and we use the above relation, and from where we know that there's one pole is at the j omega axis, so we can use that and to calculate the k values. Okay, so angle of departure, that we need to know how we do that. We know that how to calculate the j omega axis, crossing for j omega axis. Okay, so again this one comes here and it goes to this, so this is the and this point we need to calculate, and this point is known as break in or breakout points. So because this is coming in, so this is known as break-in point. If they are going out, it is known as breakout point. So we will discuss this, how we do that. We have to use the characteristic equation to solve this one. And the last one, where we have two zeros and pole, again we know that number is different, one goes to infinity, so nothing here, and we know that it will start here and this goes to infinity in that direction. Now because we know that one goes to this zero, other coming from the infinity, because it will coming from the infinity because the one pole is missing, so it is not going in that, it is coming from the infinity. So one goes in that direction, other goes in that direction, so it depends at which angle this will move at which point. So I think this will move something like this, and this will move something like from here. Okay, so it will finish like this. So this is a freehand sketching, but exactly how it do it, so we will need to do the calculation. Either this will go in that direction or in that direction. So for that calculations we need some other information. So for if we write here for calculations of root locus, so what we need one thing. First one is location, zeros and poles. Second thing is asymptotes. Okay, so asymptotes has location, that is represented by epsilon, and angle, that is represented by theta. Okay, third one that we need j omega crossing, that we use using Route's table, Route's criteria. Okay. Fourth one we need is break in or out points, that we calculate using a characteristic equation. Okay, I told you how to do that. And fifth one is angle of arrival and departure. So this is the whole story when we able to do all these things, we easily calculate and precisely draw the root locus. I will stop here. Thank you. We will discuss how we next how we do geomag axis, break in, break out, and angle of departure. So after that, we done with this root locus plotting. Thank you.